Welcome to Ask and Learn.
Okay, so the total magnetic flux can be equal to phi air plus phi liquid, and phi air is equal to B air plus, times A air, and phi liquid is equal to B liquid times A liquid. B air is the magnetic field at the air part, and A air is the area at the air parts, and B liquid is the magnetic field at liquid part, and A liquid is the area at liquid part. So we know B liquid, A liquid can be equal to Km mu 0 Ni over W times dW. Km here is the relative permeability of the liquid. Okay, and the mu zero is the permeability constant, and I is the current, N is the number of turns, and W here is the width of the tank, and D here is the height of the liquid. So as you can tell, W can be cancelled out, and this will give us mu 0 Ni Kmd is equal to B liquid, A liquid. And B or A air is equal to mu 0 Ni over W times D minus D times W, since we know A air is equal to D minus D times W. And as you can tell, W can be cancelled out. And this will give us B air A air is equal to mu 0 Ni D minus D. So therefore have the total magnetic flux is equal to mu 0 Ni Kmd plus mu 0 Ni D minus D, which will give us mu 0 Ni times Kmd plus capital D minus lowercase d. Therefore have L, which is the inductance, is equal to N phi over I, which will eventually give us mu 0 N squared times Kmd plus D minus D. So if we expand it, we'll have L is equal to mu 0 N squared Kmd plus mu 0 N squared times capital D, and then minus mu 0 N squared lowercase d. So let L0 is equal to mu 0 N squared capital D, and LF is equal to mu 0 N squared Km lowercase d. This will give us L is equal to L0 minus L0 lowercase d over capital D plus LF times lowercase d over capital D, which will give us the height of the liquid, which is lowercase d here, is equal to L minus L0 over LF minus L0 times capital D. So for the second question, we know L can be equal to L0 times 1 plus xm times lowercase d over capital D. Xm here is the magnetic susceptibility of the liquid oxygen. Okay, so we know L0 is 0.63 Henry, and xm is equal to 1.52 times 10 to the power negative 3. So therefore, we'll have L is equal to 0.63 Henry times 1 plus 1.52 times 10 to the power negative 3 times lowercase d over capital D. So we know when d over d is equal to 104, we'll have L is equal to 0.63029 Henry. And when d over d is equal to 1/2, we'll have L is equal to 0.63048 Henry. And when d over d is equal to 3/4, we'll have L is equal to 0.63072 Henry. So when lowercase d over capital D is equal to 1, we'll have L is equal to 0.3096 Henry. And for the next question, so for mercury, we know L0 is the same, which is 0.63 Henry, but the magnetic susceptibility is different. So the xm for the mercury is negative 2.9 times 10 to the power negative 5. If we plug in, we'll have such equation for L. So when d over d is equal to 1/4, we'll have L is equal to 0.63000H. And when d over d is equal to 1/2, we'll have L is equal to 0.62999 Henry. And when d over d is equal to 3/4, we have the inductance for the liquid mercury is 0.629999 Henry. And when d over d is equal to 1, we have the inductance for liquid mercury, which is out here, is equal to 0.62998 Henry. So for the last question, well, my answer is, it should be oxygen. Okay, so the liquid oxygen is more practical. Okay, it's because there is an easily detectable spread of values for the liquid oxygen, but this is not the case for the mercury. Okay, so therefore the answer should be liquid oxygen is more practical. Okay, And these are the answers for this question.